So for whichever reasons, the guys more to the right, these ones, they feel like the tax rate should be higher, and the guys more to the left, these ones, they feel like the taxes should be lower, right? We now returning to what we talk, how we talk about all of that. This is called the unidimensional policy space. Policy space. The reason it's called that way is because, well, first, it's a policy space, right? We're talking about some kind of a policy here. The policy is how much you tax away from the people's income, and it's unidimensional. Oh, sorry. And it's unidimensional because it's only one dimension, right? So it's only from less taxes to more taxes. In principle, and that's just kind of an aside, we could imagine that there would be more than one dimensional policy space, like a two-dimensional policy space, which would look something like that. And for instance, here we would have taxation. That would be taxation. That would be first dimension, and the second dimension would be something cultural, for instance, support for the language, for languages. So we could imagine that there would be this society, and people in this society, they would be caring for how much money is being taken away from them every month in taxes. But there would be also the second dimension, the second important area for them, whether more or less languages are allowed to be used in school education, for instance. So there would be people who are more culturally liberal, more languages. They would say that every location would be allowed to use the language of their own. And you can imagine in a multi-ethnic society that could be an important issue. So these people are more liberal. And here, for instance, there would be people who would say the less languages, the better. For instance, there's just this one national official language used by the majority, like for instance Russian language in Russia or German language in Germany, and that's the only language that should be used for education at school. So for instance, in the United States, there are people of all kinds of origins, all kinds of languages, and sometimes they live in, these compact groups, like, that Italian Americans live here, Caribbean Americans live there, and something like that. But there is just one language used in education, the English language. And this would be a two-dimensional policy space. Two-dimensional. And you can imagine that there could be a three-dimensional policy space, an n-dimensional policy space, etc. When we talk about the median voter theorem, we focus on this unidimensional policy space. A policy space which only has one dimension to it. And that's an assumption for us about this particular society. We think that in this particular society, voters are primarily motivated by just this one dimension. Now, once we have this dimension, and once we have placed the voters at these points, we can start talking about how they would be behaving, and more specifically, who they would vote for, right? So these points where they are located, for instance, this one or this one or that one, they are called the ideal points. So for instance, for this particular voter, the ideal point is 48%. And for this particular voter, the ideal point is 60%. And then what we do is we ask ourselves, so imagine that there is this and now we start talking about the median voter theorem. Imagine that there is this society with voters placed in a unidimensional policy space, and imagine that there are these two candidates, the red and the blue candidate, or the left and the right candidate, or candidate Smith and candidate Jones, or whatever. And they participate in an election where there are just two candidates, and the candidate wins if he or she, if they get the majority of voters voting for them. So in such a situation, what would be the behavior of the two candidates in the equilibrium, right? So and so, you know, starting to talk in terms of game theory, we have the two players in this game, candidate left and candidate right. We have their strategies. Their strategies are, let's say that their strategies are numbers from 0 to 100, right? And these strategies stand for the tax rate that they will use for their campaign. So for instance, a candidate could say, I will change the tax rate and it will be 17.5%, something like that. That's one of the possible strategies. And finally, utility. We will say that utility for a player here is one for winning in these elections or 0 for losing. Or one alternative way to determine utility here would be to say that utility equals to probability of winning. So the candidates are trying to maximize the probability that they will win. Now, the median voter theorem it states that both candidates here will pick as their position, the position on which they will run, the position of the median voter. So we could say that the position XL in the policy space here, the position taken by the left candidate, as well as the position of the right candidate, XR, in equilibrium, and that's why I'm drawing this little star, the asterisk, would equal the position, the ideal point XM. And this XM is the ideal point of the median voter. That's what the median voter theorem states. In this kind of situation, an electoral race with two candidates competing in this constituency with just one-dimensional, unidimensional policy space, the candidates, if they try to maximize the probability of winning, will have to pick the ideal point of the median voter as their strategy, right? Now, one last thing that we have not discussed is who this median voter is. To find the median voter, what we do is we look at voters situated in this policy space we count them. So for instance, here I count them and I can see 1, 2, 3, 4, 5, 6, 7, 8, 9, 11, 11 voters, right? 5 here, 5 there, 1 here. Yeah, they should be 11 voters. Out of 11 voters, the median voter is the one situated in the middle. So it's the one who has 5 voters to the right and 5 voters to the left. Here it happens to be this guy. This is the median voter. Median voter. And that means that the XM, the ideal point of the median voter in this particular setting, happens to be 60%. This one, right? Notice, importantly, that 60% is not the average between 0 and 100. It's not the average between the ideal points of all of the voters. It's just the position that the median voter, the one who has the equal amount of other voters to his or her left and right, it's just this position that the median voter prefers, his or her ideal point. Both parties will have to focus on this position. That's the median voter theorem. To prove it, and with theorems, the important part is that we prove them, we could use a technique which we know already, a technique called the iterated elimination of dominated strategies, right? So for instance, here we could say that we just will divide all of the voters in this policy space into equal amounts. Well, for instance, here we could just, given that there are just 11 voters, we could just divide them one by one. So for instance, there would be the first voter here, second here, third there, fourth, fifth, 6, 7, 8, 9, 10, and 11. And what we could do is we would just focus on each of these voters as if they were strategies for the candidates, and we would pick we would pick them one by one, and we would check whether this particular strategy is actually dominated by some other. So for instance, we could start with the voter number 1 and imagine that that candidate left, and left is just his last name here, right? It's not like he's left wing or right wing. That's his name. Stephen left, for instance. So if left decides to play 1, picks the ideal point of the first voter, x1, and it's equal to 2% in this particular situation, but that does not matter. Then let's see. Imagine that that right also plays x1. If right also plays x1, that means that candidate left and candidate right are exactly the same from the perspective of all of the voters, right? And that means that the voters, they say, okay, these two guys or two girls are exactly the same from my perspective. They're both campaigning on 2% tax rate. So I'm completely indifferent between the two, and I will just vote for each of them with probability 1/2. I'll just toss a coin or something, because I have to decide somehow, right, for whom I will vote, but I cannot make any informed decision. They're exactly the same. And that means that in this situation, the probability of winning for the left and for the right, these two probabilities are equal. They're 1/2, right? Now imagine that candidate left, instead of sticking to the strategy of playing x1, would move to x2, move to this point. And the candidate right still plays this strategy. What that would mean is that candidate left would become closer ideologically to all of these voters. Ouch. He would no longer be the closest to this one. So this, the first voter, would vote for candidate right. But all of these guys, the third, fourth, fifth, sixth, seventh, etc. voters, would prefer candidate left now. Candidate left is now closer to them ideologically. So they would vote for him. That means that for right, we would have one voter. For left, we would have all of those from number 3 to number 11. That's 9 voters. And then the second voter would also prefer candidate left, right? Actually, candidate left in this situation would be ideal for the second voter. So actually, they would be 10. Now, you can imagine that that means that against right playing strategy 1, for left, strategy 2 clearly dominates strategy 1. But it's the same with all other possible strategies that right could play. So for instance, right plays strategies to the right from x1. So for instance, x2. If right plays x2, then for left, then they kind of swapped places here, right? If left sticks with 1 and right now plays 2, then right gets 10 voters and left gets just 1. However, if the left candidate moved one step to the right and also played x2, also picked the ideal point x2, then all of the voters would suddenly become indifferent between the two candidates, and they would, one half of them would vote for the left. Well, they would, with probability one half, they would vote for the left candidate, and with probability one half, they would vote for the right candidate. And that means that just by moving to the right from the first voter to the second, candidate left would increase her probability of winning from 0, right? Because if you only have one supporter and your opponent has 10 supporters, you lose for sure, to one half. That's an increase. And of course, if in this situation you move to the third voter, to x3, then you even further increase your probability of winning against the other candidate who stays at x2, right? Because then you get all of these people and the third voter, and your opponent only has these two. Now it starts getting messier, but if you repeat these steps, and by the way, you can start both from the left and from the right, then what you would see is that normally strategy 2 would strictly dominate strategy 1, or if you started from the other side, you would see that strategy 10 dominates strategy 11. But then strategy 3 would strictly dominate strategy 2, and strategy 4 would dominate strategy 3, and the same would happen on the other side. So 9 and 10 and 8 and 7 would be dominated. And by going this way, you will come to strategy 6, to x6 or xm, the median voters' ideal point. And with the median voters' ideal point, it is kind of important to see that this xm, it has equal amount of voters to the right and to the left, right? Here and here. And that means that imagine that you are the left candidate and the right candidate picked strategy XM. If you also pick, if you respond with XM, then the left and the right are the same, right? They are indistinguishable from the perspective of these voters, and therefore they each win with probability 1/2. However, if you respond with anything different than XM, not XM, then, for instance, if you move to the left here in this picture, right? Imagine that XL is somewhere here. Then you only get all of these voters who prefer you. The right candidate who picked XM still gets all of these voters, right? And you can already see that these must be smaller than these, the numbers of voters themselves. And these guys in the middle, the ones between XL and XM, all of the voters here, they are divided in half. So half of them vote for XM and half of for XL, and half of them vote for XR. Half of them vote for candidate left, and half of them vote for candidate right, who picked position XM. And candidate right wins with certainty, with probability 1, because this is greater than this, right? That kind of stuff. It appears that by iterated elimination, we come to a situation where XM, the median voter's ideal point, appears to be the only strategy that the players have left. And then we show that these two positions, XL and XR equal to XM, are a mutual best response. They form an equilibrium. Now, you will remember that, okay, so you can see that's kind of messy, the stuff that we have here. But we started by speaking about the median voter problem. The problem here, from the game theoretic perspective, is that in many cases, we actually, even if you have just two candidates and a unidimensional policy space, etc., what you see is not that the two candidates are exactly the same, that they campaign from the same positions, right? They are kind of different. And in reality, when you look at two-party systems, quite often you see that there would be this left-leaning party, left-wing party, some kind of socialists, or the Labour Party, or the Democrats in the United States, or Le Mouvement Réformiste in Belgium, or something like that, which are kind of, for the higher taxes. And then there would be a different party, and it's not like they both take the same position. The more liberal party would be for smaller taxes, and there would be a huge, or at least a noticeable distance between the tax rate proposed by the more liberal party, economically liberal, and by the more socially responsible party, right? So it seems very logical from the median voter theorem that the two parties or the candidates running on these parties' tickets, they should pick the same position, but in reality they don't. And that's a problem, right? And that's like the problem that I want us to think about in this class.